Okay, today we are going with section 8, Astrophysics, IGCSE Edexcel, last topic over there. If we talk about it, we will have to go for, first of all, the universe over there. The universe. This is the last section of your physics subject over there. If we talk about the universe, there are all sorts of exciting stuffs in the universe, and our whole solar system is just a small part of huge galaxy, in which we can say galaxy. Galaxy, it is a collection of billions of stars. Billions of stars over there, and universe is going to be taken as a collection of billions of stars, in which I am saying our solar system or our sun is a small one star only. If we talk about that galaxy, that is named as Milky Way over there. And if we talk about Milky Way, the universe is a large collection of billions of galaxies, and galaxy is a collection of stars. Our sun is just one of billions of stars from the Milky Way galaxy over there. And our sun is about halfway along one of the spiral arms of Milky Way. It is the galaxy in which our sun is halfway halfway one arm to complete galaxy over there, halfway along one spiral arm, along one spiral arm over there in of the Milky Way, of the Milky Way. What does this mean, that the what is spiral arm? If we take a galaxy, Milky Way, if we show the galaxy over here, for example, galaxy is being shown like in the form of curves like this, then your sun is like here, it is present, it is halfway of a Milky, one arm only, and remaining all to all is a complex galaxy of Milky Way over there. And the distance between the neighboring stars in the galaxy is often millions of times greater than the distance between the planets in our solar system. So if I say in my solar system, there is Earth, Venus, and some other Neptune, Pluto, Neptune, etc. are the planets. The distance between these stars, which are present on other spiral ways, billions of larger meters or kilometers away from each star over there. So universe is, we can just imagine how much big it is. So and the distance between the stars on different spiral ways of the galaxy over there is billions of kilometers greater than the planet's distance over there. And the force which keeps these stars together of a galaxy is called the gravity of the course. What is does mean gravity of course? Gravity of a course is the force of attraction which keeps all of these stars under the action in the huge galaxy to be limited over there. That is called gravity of course, gravity of that pathway which keeps that stars into that fixed positions over there. And if we take the force which keeps the stars together, then we can say all, like most things in the universe, galaxies rotate a bit like a Catherine wheel over there, like it is showing the rotation, and it is like rotating about its central axis, like Catherine wheel is there and it is rotating about this axis. If we just try to watch with the help of telescope or with more magnifying scopes over there, we can observe that they are rotating, to showing their rotation in the form of Catherine wheel over there. Galaxies themselves are often millions of times further apart than the stars. If I am just taking and talking about only one galaxy, that is Milky Way, there are also billions of galaxies are also more present over there. Billions of galaxies are also present over there, which are also much at larger distances like stars over there. Far stars, I said that are billions of kilometers away, like planets, greater than planets. And in galaxies, I'm saying that galaxies are far apart from their distances, like the stars, which are separated on the spiral arms of the any galaxy where we under a discussion over there. So the universe is mostly empty space and really so big. So we can say the universe, which we were starting to discuss over there, it is very big, which we can only imagine. And continuously your universe is expanding according to Big Bang theory over there. Big Bang theory. Like he is telling us that Big Bang theory states that our universe is continuously expanding over there. All the stars are moving away from each other to show that they are being taken in the form of complete section over there. After that, our solar system has one star, the sun over there. Our solar system. Our solar system has one star only. And if we talk about one star, then we can say all the stuff and that orbit the sun is included. Our solar system is all the stuff that orbits the sun, like all the planets which are revolving around the sun, like Earth etc. is all the stuff of our solar system over there. And the planets are all large objects that orbit the star. First of all, the planet are the large objects which are going to revolve around the sun over there. The 8 planets in our solar system are in order from the sun outward. Number 1 is coming as Mercury, the order, and in the sequence as the order is increasing, they are moving away from each other. And after Mercury, we can say there is Venus and then Earth. Venus. Number 3 is Earth. Number 4, we should discuss about that. That is Mars and then Jupiter. Mars. Number 5 is Jupiter. And in the last, second last over there is Saturn, Uranus, and Saturn. After that, Uranus and Neptune. Uranus, and at number 8 is Neptune. And the number 9 was Pluto, which was nowadays a dwarf planet, dwarf planet over there, which has been released from the outer surface of our gravitational pull of the sun over there. So this, just remember that Mercury, Venus, Earth, Mars, as the increasing radius is going to happen, everyone is going to be under the gravity of the sun and they are revolving around the sun over there. So dwarf planets like Pluto, these are planet-like objects that are not big enough to be planets, and they are gone away or something like that. After that, there are moons. Moons are those natural planets which are natural satellites. Moons are natural satellites which are which are revolving around which are revolving around planets over there. As we look above, planets revolve around sun over there, and satellites or moons are revolving around the planets. What is the difference between planet and a star over there and satellite over there? Star is a luminous entity in which I can say star has its own light, and planet does not have its own light. It needs to light fall on it so that it can show some shine over there. For example, you look the moon or you look the earth, which is shining at daytime, at nighttime moon is shining. A reason behind that, that the sun is throwing as a luminous source of light on its surface, and it is glowing like a shining entity over there. After that, planets, there are satellites. Satellites are also the non-luminous objects over there, in which we can say they revolve around the Earth, and also they are being controlled with the solar system over there. After that, if we go towards artificial satellites are human-made artificial satellites are human-made entities or objects which are sent to the space at the speed of the planet rotation over there. Like Earth is revolving with some about its rotational speed, or orbital speed over there is exactly similarized, so that your artificial satellite can stay on above the surface of your country over there, which is launching this. And it is artificial satellite is used for telecommunication purposes over there, and one humans built and usually orbit the earth in fairly circular orbits over there. After that, there are asteroids are basically, we can say, lumps of rock and metal that orbit the sun. Lumps of rock and metal that orbits the sun over there, and they are usually found in asteroid belt. They are present in asteroid belt over there. And if we talk, the last section of this solar system is called comets. If we talk about comets, comets are basically lumps of ice and dust. Ice and dust that orbits the sun over there, and their orbits are usually highly elliptical, a very stretched circle. Their orbit is highly elliptical orbit, in which they are surrounding, they are revolving around the sun over there, and some travels near the sun, and sun to the outskirts of our solar systems, they are revolving around them. For example, I just draw here a little bit structure over there which can easily explain over there. This is our sun, and the planets are revolving around it. This is sun, and in the first orbit, if we just observe, the Mercury is in the first orbit. And if I draw 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, and at number 8, the last planet, Neptune, is present over there. They all are revolving around the Earth. As we go away from the sun, the planets are getting colder. Very nearer is very hotter due to high temperature of earth over sun over there, to put it over there. And the comets and the asteroids are not revolving around them. They can have some elliptical pathway around it. They can be in the form of ice, melted ice, or in the form of small particles like around it, which is showing the asteroid belts in case of asteroids. And comets can also be taken highly elliptical pathway around the sun over there. After that, this sun is providing the gravity for the planets, for the satellites, for the comets, and for the asteroids over there. So the planets move around the sun in almost circular orbits, as I have shown you in the form of 8 numbers over there. And same goes for the moon and earth over there will be being taken. If the object is traveling in a circle, constantly changing direction and constantly acceleration, which means there must be a force acting on it. And according to centripetal force, which keeps the body to move on a circular path, we can simply say here that the gravity of the sun is providing a continuous force, because when the Earth or planet is moving on a circular track over there, at every point they have their different tangential direction. Even though your velocity is constant, but the direction is changing. When the changing of direction is happening according to it, then we can say that they are having some acceleration over there. If the acceleration is present for all of these planets which are revolving around the sun, then it is being called, given with the help of centripetal force, which is always directed towards the central position over there, center of Earth over the center of sun. It will always be directed towards the sun over there, which means that the centripetal force is always directed towards mean position over there. And this force causes the object to fall towards, and like Pluto or some other, if they don't have the proper force of repulsion, also they can't balance this. So centripetal force and gravitational force both are getting equal, which I can say gravitational force is equal to centripetal force, which both are responsible for the planet to revolve around the main star of the sun over there. The object keeps accelerating due to direction change, as the velocity is constant when they are revolving around it, and instantaneous velocity keeps the traveling in a circle, and the force makes what happens provided by gravitational force is gravity, and the gravitational attraction of the sun keeps the planets and comets in their orbits around it. So your planets are staying in their orbits, and comets and asteroid belts over there are balanced with the help of strong gravity of the sun. Satellites are kept in their orbits around the planets by gravitational attraction of planets over there. This whole where I have used over there planets, I said about asteroids, and I said about we can say comets. Everything is present under the action of gravity of the sun over there, and the satellites are acting under the action of gravity of the planets over there. Like moon is the planet of Earth, so Earth will responsible. Earth is a planet, and moon is a natural satellite that will be responsible for providing the gravity over there. If we talk about gravity, which I just has said that the sun is providing and the planets are providing for their moons over there, then the force due to gravity depends on mass and distance. What I am saying, that the force of gravitation directly proportional to masses. This is law of gravitation, which in detail will be explained in A levels over there. And gravity is also present over between inversely proportional to square of distance between their centers over there. So force of gravity, force of attraction between two masses depending upon the masses. If, for example, the Earth is a big mass, and a person who is sitting on the Earth is a very small mass as compared to it. For example, Earth mass is 6.0 multiplied 10 raised to the power 24 kg, and the human mass is only 50 to 70 kg, like that. So this small object is exerting negligible force, but the Earth will exert a very significant force, which is required for walking while you are sitting. Gravity is less, and if you want to stand up and walk over there, it means a huge gravity. You will have to work against that. So we can simply say here we have the basic concept of weight over there. What was the weight? Weight was basically a vector quantity which was always directed towards downward under the action of gravity. W is equal to mg. You have studied in the previous section of dynamics over there, measured in newtons, and spring meter, spring balance. And our Newton meter was used for measuring the weight of any object over there. That is also done because of this gravitational acceleration, which we're talking about gravity. That is gravitational field strength G, in which we can say that is weight per unit mass, is called gravitational field strength over there. And it depends on mass of the body creating the field. Like as the mass is larger, gravity will be smaller. If the mass is smaller, gravity will be maximum over there. And this G value varies from Earth to Moon, like that. G value at Earth is 9.81 meter per second square. You can also take 10 or 9.8 over there. And for Moon, gravitational acceleration or gravity is being taken as 1.62 meter per second square. So all of these gravities are responsible for the formation of fixed orbits over there. The Earth is more massive than Moon, so the object would weigh more than on Earth. For example, you are going to measure your weight like 10 kg. You want to measure on the surface of Earth, then it will be 100 Newton. But if you go for 10 to be multiplying by measuring the mass, your weight on the surface of Moon, it will be just 16.2. 16.2 as the weight of 10 kg, surface will be taken as 16.2 kg over Newton over there. On the other end, if you go for Earth calculation, that will be 100 Newton approximately, or 981 Newton over there can be taken into account. Even though the masses for both cases is 10 kg over there can be taken into account. So gravitational field strength varies distance closer to get a star planet, stronger the gravitational force. According to this law of gravitation, I have already told you. And if I go for stable orbit, or the stronger the force, the larger the instantaneous velocity needed to balance it. So the closer to a star, the planet you get, the faster the need to get remain in orbit. And stable orbit is also present if the speed of object changes, and the size of radius of the orbit must do so too. So faster moving objects will move in a stable orbit with a smaller radius over there. There are different types of orbits over there in which we can say they can be slightly elliptical, slightly elliptical. Orbits are present over there. After that, we can also say that when slightly elliptical present, then comets orbits the sun, but have very large elliptical pathway. For the example where I said slightly elliptical pathways, that is occupied by moons, that is occupied by planets over there. They are very slightly elliptical. But when we talk about comets and asteroids belts over there, then we say very large elliptical. Very large elliptical pathways over there are present, in which we can say that we will have to take comets and asteroids belts over there are the examples which are following this type of pathway, which is very much elliptical in the form of orbit over there. And comets have orbital period much longer than the Earth or planet over there. So when they have a large elliptical pathway, their time period to complete its one cycle around the star over there will be much very large, due to not have a proper circular pathway because they are in the form of elliptical pathway over there. And we can also say a comet travels much faster when it is nearer the sun, because if I'm taking the sun over here and the pathway is like this, and when it is nearer to the sun, it will move at faster speed. When it is far away to the sun, then it will move a very slow speed over there. Because and this will speed up because why it speed up near the sun over there? The reason behind that the force of gravity which is attracting the comet when it is nearer to the sun surface will be much larger in that case over there. So pull will also increase and it will speed goes at higher levels. Some artificial earth satellites have an orbit of period exactly 1 day, because if this is the earth and this is the launched satellite over the surface of a special country which has launched it, and its rotation, the earth is rotating about its axis over there, it should remain at the surface of it. So the period of artificial satellite and period of 1 day of 24 hours of earth should be the similar over there, so that that satellite can be used easily for the telecommunication purposes for exactly the same country over there. And if you want to calculate the distance traveled for according to speed calculation over there for orbital speed with which it will travel around the earth at a constant speed over there, that it can behave as geostationary satellites over there. For that one, we use our circular orbit, the distance traveled over there, which is being taken by 2 pi r is the total distance divided by time can be taken for orbital speed of the formula with which the object is going to rotate over there. So I can say here r is the radius of orbital radius. It is not the radius of Earth. It is not the radius of planet. It is basically the distance from the artificial satellite to the Earth's surface over there, so that you can check with how much orbital speed it is revolving around the about its axis, and also revolving the Earth over there. Rotation is being shown with the help of this formula. This type of question, by using the formula 2 pi r over t for calculation of orbital speed, is important for examination point of view over there. After that, there is stellar evolution, how stars is being formed. Then there will be classification of star, red phase shift and blue shift will be taken into account. In the next video, I will try to cover up and finish this whole topic over there. But right now, I'm just going towards the formation of star over there, in which I am writing here the star is being formed. Formation of star. Formation of stars over there. Remember that there are different stages in which, first of all, the formation of nebula. What is nebula is, first stage is, first of all, I'm just writing the names over there. Nebula is the first stage. After that, second stage is named as protostar. Protostar over there. Next one is being taken as main sequence star. Star over there. At number 4, we can say that is a star much bigger than sun, and star taken as smaller than sun. Then main sequence star is divided into 2 more equal parts. When it is greater than the sun size, then we can say it is a red super giant. And when it is smaller than the sun size, then we can say only red giant over there. And from the red supergiant, the formation of supernova is going to happen over there, which will be going to make more black hole and neutron star. Neutron star and black hole is going to form over there. And when we go for red giant over there, then we can say red giant is going towards white dwarf plants over there. White dwarf is going to form over there. If I talk one by one about, first of all, I am talking about nebula. Nebula is stars initially form a cloud of dust and gas. So it is cloud of dust and gas, which will be formed because of the first stage of nebula over there. After nebula, there is for the section 2, that is the formation of protostar over there, that the force of gravity pulls the dust and gas together to form a protostar. Means gravity will be introduced at the formation of protostar over there, which will combine the clouds of dust and gas over there together, and the protostar will be formed over there. And the force of gravity that pulls the dust and gas together to form a protostar, the temperature rises as the star gets denser and more particles collide over there from the gas particles and dust particles over there, and with each other. And when the temperature gets too enough, hydrogen nuclei undergo nuclear fusion. As I said, that the cloud of dust and gas. So when there is the formation of hydrogen atoms over there to be fusing over there, then the helium is going to formed by the process of nuclear fusion over there. That nuclear fusion is responsible for the formation of larger molecules over there, and to give out huge amounts of energy under the reaction of nuclear fusion. And in the previous videos where nuclear physics was explained over there, you can easily observe what is the nuclear fusion, where two smaller nuclei are combining up to make the larger nuclei, with the release of a huge amount of energy can be taken as a nuclear fusion process over there, and which keeps the core of the star hot, and star hot is burned over there. In case I can say here that when nuclear fusion is formed over there, then protostar is giving their core. Core means the outer surface of the star very hot, and here we can say a star has been produced, a star has been born over there. After that, there is a long stable period. During this period, the outward pressure caused the thermal expansion. The energy produced during the nuclear fusion tries to expand the star balance, and the force of gravity pulling it to inward, meaning making the main sequence stars over there, means high pressure is introduced. For this case, high pressure after the core is very hot and it is going to make in a proper shape over there, then we can say that main sequence star is being introduced by high pressure over there, and it is typically several billion years is taken for lasting over there. The heavier the star, the shorter the time on the main sequence over there. Means main sequence star is basically, if it is a heavier star like a red supergiant, then it will be shorter time. If it will be red giant like a smaller in size, then it will take more time over there. So eventually, when we say that the hydrogen in the core begins to run out, and the force of gravity larger due to pressure up to above two cases, then we can say dense hot red supergiant and red giant are going to be formed, because the red is due to high temperature. When you are burning something, the first color which is observed due to high temperature is a red color, according to the rainbow sequence of Webb Boyer, and it is having the minimum frequency and largest wavelength for red color over there. So red supergiant will be observed, and red giant will be observed as a hotter object over there. And in case of red supergiant and supergiant, when I say red giant is being taken for the white dwarf case over there, then a small to medium sized star like the sun then becomes unstable and ejects the outer layer and dust of gas, and this leaves behind a hot, dense, solid core like a white dwarf over there. When we move towards big stars like red supergiant, then we will have to go for supernova over there. Big stars, however, are start to glow brightly again as they undergo more fusion, like for the formation of helium, like that over there, and they expand. Contract several times, and as the balance shifts between the gravity and thermal expansion, eventually they explode in a supernova. So they are going to explode over there. When they have exploded, then they can go towards the neutron star or going towards the black hole over there. The exploding supernova throws out the layers of dust of gas into space, leaving the very dense core called neutron star, which is, I said, very dense core over there. That is, a very dense neutron star has been formed over there, leaving a very dense core of neutron star. If the star is massive enough, will collapse and becomes a black hole. It means this is super. In the case of supernova, if some neutron star is much massive, then it will collapse and will produce black hole over there. And this black hole is super dense point in space that not even light can escape from it. So we can say that is called black hole there. This was all to all the production of stars. Tomorrow we will move towards the classifying stars and red shifts, a little bit Doppler shift and Doppler effect over there, and Big Bang theory, and this topic will be closed.